All right, guys, I am here to help you with your Mobymax. I know many of you are struggling with some of these problems dealing with speed and distance and time, and so I wanted to create a video that would help you out just a little bit. So watch each of the different types of questions that I have, walk through them with me, give them a try, and see if this might help you a little bit. This first question asks, a bus traveled 472 miles at a constant rate in 16 hours. What was the speed of the bus? All that we need to figure out is how many miles per hour the bus is going. In order to do that, we are going to be setting up a line equals line. We are setting up equal proportions, and we're looking at, oh, look, it says that the bus traveled how many miles in how many hours. So we know that it went 472 miles in 16 hours. And if we look at the answer, it's asking us miles per hour. So over here, per hour means per 1 hour. And we don't know how many miles it goes in 1 hour. When I do this, I'm simply going to cross multiply and divide. And of course, we can also just look at this as unit rate. And when I say unit rate, you say divide. And you could simply divide 472 by 16, which is the same thing that we would get by multiplying 1 times 472. And we divide that by 16. And our answer becomes x equals 29.5 miles per hour. This next question is asking us to calculate the distance from constant speed. It tells us that light travels at 186 miles per second. Wow, that's pretty fast. And it tells us, it tells us that light takes about 1 1/3 seconds to travel from the Earth to the moon. We need to calculate the distance between the Earth and the moon based on the speed of light, and our answer is going to be in miles. So let's set up our proportion. We've got our line equals line. We've got our miles per second, and we know that light travels at 186,000 miles per 1 second. Now, if it's going to take us 1 1/3 seconds, that's going to go down here under our seconds, 1 1/3 seconds, and we want to know how many miles that is. It might look a little bit scary, but all that we're going to do is multiply 186,000 by 1 1/3. So what does that look like? Well, we're going to set this up 186,000 times 1 1/3. Now, we know that when we multiply fractions, we can't just multiply by 1 1/3. We're going to change it into an improper fraction by multiplying 3 times 1. Add the 1 for the numerator, and we get 186,000 times 4/3. Now, we look at this and we go, oh, well, what do I do? Well, 186,000, remember, every whole number has a 1 underneath. We put a 1 over there, and we multiply our numerator straight across. When we multiply 186,000 times 4, we actually get 744,000. And then we multiply 1 times 3, our denominator straight across, and we get 3. Once again, I'm looking at that thinking, okay, 744,000 divided by 3, because remember, fractions really mean division. And when I divide those out, my answer becomes x equals 248,000 miles. Wow, that's pretty far between the Earth and the moon. This next question is similar to the past questions. If it took 3.5 hours for an airplane traveling at a constant speed of 550 miles per hour to reach its destination, what distance did the airplane travel until it reached its destination? Once again, let's set up our line equals line. We're setting up our proportion. We've got our miles to hours, and we know that an airplane will go 550 miles per 1 hour. Well, we know that this airplane went for 3.5 hours. So how many miles did it go? There's lots of different ways to do it, but if we set it up in a proportion, we can see our miles and our hours. In fact, I'm going to write them right here just to remind us. And when we solve a proportion, we multiply across 550 miles times that 3.5 hours, and you would, of course, then divide by 1. But when we do that, 550 times 3.5 hours, 3.5 hours, we get x equals 1,925 miles. So that airplane over 3.5 hours has traveled 1,925 miles. Now, these are the types of questions that kids are really struggling with, because the question says you jog 11 kilometers at an average speed of 10 kilometers per hour. How long did you jog? And you think, okay, well, I can set up my line equals line and let's do our line equals line. And I've got kilometers and I have hours. And we know that you're jogging 10 kilometers per hour, 10 kilometers per hour. And we know that you actually didn't just go 10 kilometers, instead you went 11. So it wants to know how many hours and minutes did it take for you to jog those 11 kilometers. The problem comes in because hours and minutes are there. We're going to get an answer, and we're not going to really know what to do with it. So let's take a look at a couple of things that we could do. The one way I like to look at this question is I think, well, because my answer is going to be in hours and minutes, instead of setting up kilometers to hours, I'm going to set up my kilometers to minutes. This is an easy conversion for me to do because I know if I can run 10 kilometers in 1 hour, I could actually jog 10 kilometers in 60 minutes because there are 60 minutes in an hour. When I do this and I put my 11 kilometers over there and I cross multiply and I divide, I get x equals 66. Now remember, because I've cross multiplied and divided, 60 times 11 divided by 10, and I've gotten my x right here, I'm actually getting my answer in minutes. But the question up above does not ask for hours and minutes, or just straight minutes. It's asking for hours and minutes. So then I have to figure out, well, how many hours and how many minutes are in 66 minutes? Well, you and I all know that there are 60 minutes in an hour. So if I were to subtract out 60 minutes for 1 hour, I would have 6 minutes left. So this 60 minutes is equal to 1 hour, and this leftover 6 is equal to 6 minutes. So my answer up above would be 1 hour and 6 minutes. Okay. So now there is another way that we can solve this problem, and I'm going to show you how to do it right here. We can go back to that original proportion of kilometers per hour, line equals line, kilometers per hour, 10 kilometers per 1 hour. If I go 11 kilometers, how many hours and minutes is it going to take me? When I do this and I cross multiply and divide, the 11 times 1 divided by 10, my answer actually is x equals 1.1. Now, many of you, when you get to this point, because you've set everything up correctly, you say, oh, that's 1 hour and 1 minute. But it is not. It is 1 hour and 1/10 of an hour. We have to be really careful with that. So we know that this hour here this one here represents 1 hour, but this 0.1 actually represents 1/10. And it's 1/10 of an hour. So what we're going to have to do is figure out, well, what is 1/10 of an hour? Now we can logically in our head think, oh, well, if I took an hour, which is 60 minutes, and broke it up into tenths, 6 would be how many minutes would be in a tenth. But the way we can solve that using a proportion is we're going to do a line equals line. And if we have 1 out of 10, 1/10 of an hour is equal to how many minutes out of 60? When we cross multiply and divide 60 divided by 10, we get x equals 6. So there you can see I've got my 1 hour from the very beginning. This 1/10 of an hour is actually equal to 6 minutes. So my answer would be 1 hour and 6 minutes. We're going to try this exact same type of problem with another one. It says an airplane traveled 1,991.25 kilometers, or 25/100ths kilometers, at an average speed of 885 kilometers per hour. So let's look at that. There's our rate, 885 kilometers per hour. How long did it take for the airplane to travel this distance? Now, if our answer was just in hours, we could be fine and we could go ahead and set up that proportion and not have to worry about it. But the problem comes in because our answer is going to be so many hours and so many minutes. So I'm still going to set up that proportion, line equals line. I'm going to do my constant rate of kilometers per hour, and I have 885 kilometers per 1 hour, but we know that the airplane actually traveled 1,991 and 25/100ths kilometers, and we don't know how many hours. I'm going to show this cross multiply and divide. When we cross multiply and divide 1,991.25 divided by 885, I actually get x equals 2.25. Now remember, because my x is in the hour spot, this is hours. So going back to our last question, we do know for sure that it's going to be 2 hours and so many minutes. Right here, we're having that 0.25. Now, I'm going to have to convert that 25/100ths of an hour into minutes. So remember, I showed you this quick conversion. If I had 25 out of 100, how many minutes would that be out of 60? There, I would go back and I would cross multiply. 25 times 60 divided by 100, and I get x equals 15 minutes. Now, we could logically think about that for a second. If you want to think about a quarter of an hour, 25/100ths is actually 1/4 of an hour. And if we were to take that hour clock and split it up kind of like this and split it into fourths, remember that 25% of it right here, this would put us at that 15-minute mark. So it makes sense then that this would be 2 hours and 15 minutes. You could also do it the other way, where you set it up instead with a kilometers over minutes, and you would have a line equals line. That 885 would stay the same, but instead of 1 hour, it would be 60 minutes, and it would be 1,991.25 over x. And when you cross multiply and divide, remember you're going to get minutes as your answer and not hours. And you're going to have to figure out how many hours is in that total minutes. I hope with me going through all of these different scenarios, it's giving you a little bit of an idea, a better idea of how to solve these problems, how to set them up, and what it is that you're looking for. As always, email me, see me before school or after school if you have any questions.